Hello everyone, welcome to my talk about how Flutter works under the hood at GDG Lagos DevFest. I'm really excited to be here. I'm really happy to have a chance to share my knowledge with you all. And today, I'm sure after this talk you will learn more and more about Flutter and how it works under the hood. So before we get started, I want to talk a bit about myself. So I'm Sally. I've been a Flutter developer since I think like 3.5, 4 years almost. Yeah, I'm a Flutter and Dart GDE. I've been in GDE since over a year now, like over a year and a half and so on. I work as a Flutter developer at a company called Superlist. And I love community. I love doing community work, and I have founded a community in, for example, in Turkey, in my home country, also Flutter Berlin. I also co-founded it and right now co-organizing it, and I've been really active in multiple communities, and I've been giving talks for a long time. And today we will be basically seeing how Flutter works under the hood. But before we go through it, let's learn about what is Flutter. If you haven't heard about it and wondering about it, I'm sure everyone had heard about it, but let's see how it is. So Flutter is Google's UI toolkit for building beautiful apps for mobile, web, and desktop. So main topic and main point is you write the code once and you will deploy it into the multiple places. This is the biggest advantage about it. Like with Flutter, you have control over all of the pixels that you have on the screen, right? Like you can see these beautiful apps going around, and all of these are developed with Flutter. Flutter gives you a chance to do this stuff by using its own declarative UI pattern. So how Flutter works on higher level. Flutter is a really special platform, really special SDK. It uses Dart as a language. Dart is a modern language that you can use almost for everywhere, from command lines to the web apps to the mobile apps. Dart has also different types of compiling types, like just-in-time compilation and ahead-of-time compilation. Just-in-time compilation gives you a chance to have a hot reload and hot restart, and ahead-of-time compilation is actually giving you a chance to have native performance over your application. It uses aggressive tree shaking, so basically whatever code that you don't use is out of your project. It will not be compiled into your project folder. Also, it uses aggressive layering, meaning that the architecture pattern that has been followed in Flutter is using layering a lot. One thing that I mentioned before is Flutter uses its own widgets. That means you have control over all the pixels, because whatever you do, it comes from the SDK itself. It doesn't come from the platform. And it uses these widgets and renders them more and more performantly by using its own graphics engine called Skia. This is how we have Flutter in a performant way. If you look at the Flutter in the higher level, you basically write Dart code, and the Dart code that you write goes into two different funnels. First funnel is the platform funnel. So you just write the code and widgets get rendered, and Flutter only asks for a canvas from the platform to render the widgets, and it only besides that it also listens to the events from the device itself and makes some actions according to it. Another funnel is called services funnel. So it is using the device-specific technologies like location, audio, camera, Bluetooth, sensors, and many more. And for doing that, you don't have to do most of the times native code. You have packages to do so, but the communication happens via platform channels, which are logical binary channels that you basically send information from. But let's talk about how it works in the lower level. This is why we are here, right? If you Google Flutter, you will see a diagram like this. So we were talking about aggressive layering. So all of these layers like here and here, like in the widgets, in the rendering, in the foundation, all of them has a strong separation of concerns. So everything that you do on the bottom can be transferred up, but every layer has its own responsibility. And even on the outer side, the framework layer, an engine layer, an embedded layer is completely different. And these also have their own responsibilities as well. So this way, with Flutter, you're guaranteeing that you are actually making your architecture go to the right place in the right moment with the right decisions. But today we will talk about a bit more deeper. In general, we are like hanging around material in Cupertino, maybe sometimes widgets, but today you will learn about the rendering part. So, 3 trees that we are going to be focusing on today. In Flutter, architecture decision made in a way that you use strong tree structures. There are multiple tree structures, and one of them is widget tree, the other one is element tree, the other one is render object. These 3 are the ones that we are going to be focusing on, but there are like semantics tree and so on and so forth, many more tree structures within the SDK itself. So let's talk about what widget is. Widget is basically an immutable description of a UI that you see on the screen. It can be a button, it can be the whole page, it can be a text, whatever it is. They are immutable, so whatever you see there is immutable. The changes are happening with another layer of trees that is called elements, which we'll be talking about in a second. What you need to know about widgets are they are lightweight, they can be thrown out, and they are immutable, so they are actually, because of that, they are safe to use. Elements are the real heroes here. They basically represent the use of a widget by orchestrating what's going on behind the scenes. It gets the information from the widget itself, and it basically transfers those information to the responsible parts. For example, if there is something that is going to be drawn on screen, the element is going to orchestrate the rendering or the drawing operation, and the next step as render object that we are going to talk about now will be sending information to the GPU to basically pass down this order. So element is the real hero somehow here. But what is render object? It basically handles the size, layout, and painting according to information that it gets from the element. Element keeps these information because it has a huge structure behind the scenes that is communicating from top to the bottom and gets the information like size and layouting and painting accordingly. So element is doing a lot of things that we are not aware of actually. But how does these three trees work and how do they orchestrate? So let's see it by the example of the counter app that you're going to be seeing when you create a Flutter application. When you create a Flutter application, you will see an app like this, which will be doing basically an incrementing operation when you click on a button. And it consists of stateless and stateful widgets. Stateless widgets are again like immutable ones that are not going to be changed at all. Immutable, but they have a special object called state inside it, and this state is doing the change for us. Inside the state class here, we have basically some simple text, and one thing that we need to keep in mind is we will see how it changes with a button push. We will focus on this text widget now. This text widget is going to be changing the counter once you push the button, and this number is shown via the counter that you see on the screen. This text here is a widget, right? We know it, we use it. But let's see what text is made of. Text is extended rich text, and rich text is extended from multi-child render object widget. And multi-child render object widgets coming from render object widget, which means that it is another level of abstraction, and render object widget is extended from widget. Okay, now we are in the widget part that we want to see. But more important thing that you need to see here is Flutter is doing multi-layering for you here. So for example, if you use a render object widget or multi-child render object widget, you don't have to even create these render objects and handle this mess. You can actually save a lot of time by simply using what Flutter offers you. But let's keep going and see what they show us. Now we reach to the widget. But once we go to the rich text, or like when you try to create a multi-child render object, you will see that you will be asked to create an element. And inside the rich text, you will see multi-child render object element is created, and this is an element that is created by the Flutter SDK for you. And this is taking care of render object operations for yourself. Let's see what multi-child render object element is. By multi-child render object element is extended from render object element, and render object element is extended from element. So we reach to the element now as well. We are missing one point, right? Like, let's see the render object, because we've been talking about render object all the time. When you go to the rich text class, you will see that you're also asked to create a create render object sort of thing. But Flutter SDK gives you a lot of render objects that you can use, and one of them is render paragraph. It renders the paragraph for you. Just give the information about it to that. So if it's local, so if it's right to left or left to right, if it's overflowing, if it's soft wrapping, if there's a text scale factor, what is the text, and so on and so forth. So you don't have to deal with creating your own render object. And render paragraph comes from render box, and when you look at render box, it comes from render object. So technically, everything that you see there is handled for you by the Flutter SDK. But like, why is it performant, right? Like, how does update mechanism work for this? So we will use the Dart dev tools that has been created by the Flutter team for us. So this is basically giving us a chance to go over the code that we have written. Let's go. So when you run it, you can see that the text is 0 and the render object is 76E0C. I want to ask you to make a note out of it, because once you update the text, we have updated the text here. Now we are going to text C. This is 1 again, and when we check the render object, you will see that the ID is 76E0C. This means that when we change the object, when we change the type text, it doesn't actually update the other files, other objects. But why is it important? Now we will see it in detail here. The text is 1, the render paragraph is 76E0C, text is 2, it is still the same. Why is it important? Because elements and render objects are the heavyweight objects that is doing the work for us. And whatever we can use is something that is valuable. For that purpose, the Flutter has a special mechanism. So we have a text here, okay? And we are updating the text. When we update it, the Flutter SDK asks for, can I update this? Can I update it by using the same widget? And behind the scenes, it checks if it's the same type of widget here. If it's text, it should be text. If it's image, it should be image. But if it's text and it turns into image, then it means it can't update it. So if it can update, it will keep the previously created render object element, like multi-child render object element, which is the element, and render paragraph for you. But if it can update it, then multi-child render object element will be turning into, it will be recreating a new element and render object for you. So whatever it can use, it will use, but if it can't, then unfortunately it can't use it. So to recap, Flutter's technology choices to help us for giving us a chance to have a better performance with minimal effort. That is why we don't deal with all the stuff behind the scenes. We actually write widgets. Flutter has multiple tree structures within the SDK, as I said, and because of the tree structures that it has an easy way to detect and make performance optimizations. Three trees that we have focused on today was like widgets, widget tree, element tree, and render object tree. Widgets are disposable, so we can just like get rid of the widgets. They are immutable, disposable, they are lightweight, so it's better to stick with them. Elements are the real hero, they hold the real information about the widget and actually structuring it. Render objects just do the drawing and do the communication with the GPU. I gave some resources here, I left it here, and I will share it with the organizers as well. And there are a lot of nice video resources here, so please feel free to use it. And one thing that I really care about is please read the source code, because whatever information that I shared with you here, I learned it basically by reading the documentation over the source code and checking out the code itself. Thank you for listening to me, and if you want to reach out to me, this is my Twitter account, and feel free to just reach out to me with any questions you might have. Thank you for your attendance. Goodbye.